Alrighty. So we're gonna try to do some video notes today so that you guys, I can kind of talk through some of these things with you, and so instead of just reading things. We're gonna start by kind of reviewing some things that we talked about during the topic 1 notes, but we're gonna look at a different example. So this says, tennis player Rafael Nadal had been called the king of clay for his excellent play on clay surfaces. But does he really have a greater ability to play tennis on clay courts compared to grass or hard court surfaces? So here is a two-way table showing the results of his matches from 2009 and 2010. And we can see, as we looked at the other day, here are the wins, successes, and failures on the clay surface, and then the other surface, and then the totals. So the first thing we want to review is stating the null and alternate hypotheses. Remember, we want to talk about who, which is Rafael Nadal. We should talk about the year. In the null hypothesis, we talk about having the same ability. We want to look at his ability to do what, and we're looking at his ability to win. And we talk about the two contexts. So on clay courts and other surfaces. If you said clay surfaces, of course, that's fine, okay? That's our null hypothesis. Our alternate will be very similar, except the alternate is implying that maybe there's some sort of difference in ability. So again, we reference our player. But this time, this is suggesting that he might have a greater ability to play tennis on clay courts. So if that's what's suggested here, that's what we'll put. So we'll say has a greater ability to win on clay courts than on other surfaces. So that is review from what we did the other day. This is what your answer for something like 10A in the homework tonight should look like. A null hypothesis and an alternate hypothesis. The other thing we discussed is the test statistic. The test statistic that we look at in chapter 2 that we focus on is called the difference in percentage. This problem particularly is going to be the difference in win percentage. And when we talk about that, we should tell what context we're dealing with. And since we thought clay was better, we're always going to compute the difference in winning percentage and take the clay winning percentage minus the other winning percentage. So let's do that from the two-way table. So that's the name of our test statistic. Let's do some work to find its value. So the winning percentage on clay is 44 wins out of 46 total. So 44 out of 46. If you were to divide that, you'd get 0.957. And the other winning percentage is 92 wins out of 116. So we would take 92 out of 116, and that gives us about 0.793. So again, we take clay minus other, and that gives us about 0.164. So then our difference in winning percentage, you could articulate it as 0.164, or if we're talking about a percentage, we could say about 16.4%. So that is the name and value of our test statistic. Be very specific in the name. Use the two-way table to help us with our value. This is what you will be doing on your homework tonight in number 10B. Okay? So this is the newish part, is us looking at the simulation and being able to talk very specifically about drawing conclusions from the simulation. So a simulation was conducted to show the distribution of this test statistic to find out all the various differences in win proportion, clay minus other, that could happen by random chance. 100 trials were conducted, and the values of the simulated test statistic for each trial was recorded on the dot plot shown. This says describe what information this dot plot provides. Any dot plot always shows possibilities that could happen by random chance. So what we could say for this dot plot is we could say this dot plot shows, in particular, the possible differences in winning percentage specifically clay minus other, that could occur or could happen just by random chance. Again, our dot plots always talk about what could happen by random chance. Specifically, we're looking for this test statistic. So it would say this dot plot shows the possible differences in win percentage, clay minus other, that could occur just by random chance. So we want to see how special that test statistic, that 16.4, is. So to do that, we find the p-value. This is like what we did in chapter 1, where we wanted to see how special it was. We really were looking for a p-value. The p-value describes how likely it is to get performances at least as extreme or like special, so at least as special as our test statistic just by random chance. Okay? So that's what a p-value is. It tells us how likely is it to get something that special as our test statistic just by random chance. And so just like we did in our simulations in chapter 1, we're going to look at the value that's in question. In this case, we look at our p-value, at our test statistic. And remember, we never looked just at the test statistic. We looked either at or above the test statistic, or we looked at or below the test statistic, depending on if it was a better or worse. If it was better, we looked right. Worse, we looked left. Most of our hypotheses in this chapter are talking about a greater ability. So greater ability means that we would choose the at or above the test statistic out of the total trials. All right? This p-value is something that doesn't go away. We talk about it in chapter 2, chapter 3, chapter 7, chapter 10. So it's really important that we wrap our head around this, okay? We use the results of a simulation to find our estimate for the p-value, but remember that this only provides an estimate for the p-value. According to the law of large numbers, we could only get our true p-value with an infinite number of trials. So again, the only way we can get the true p-value would be with an infinite number of trials. So all the p-values that we'll be finding throughout this whole semester is going to be just an estimate. Okay. Oh, before we flip the page, the information the dot plot provides, that is going to be very similar to what you're going to do in 11A and 12A on the homework, okay? But it's not going to be the possible differences in win percentage, clay minus other. It's going to be whatever test statistic that you're dealing with in 11 and 12, okay? Hopefully we're set there. If not, again, these are online. You can go back, rewind, and watch. All right. So let's find the p-value, for the Raphael Nadal problem. We're always going to compare it to the test statistic. What was our test statistic? Well, our test statistic was 16.4%. So to find our p-value, we're going to see how many dots were at or above 16.4% over our total. We knew that we had 100 trials of the simulation, okay? It told us that here, that we had 100 trials. So there are 100 dots. That's our total trials. Now we want to see how many of those trials are as special as our test statistic, 16.4%. And we want to read the scale carefully. So for time's sake, here's 0.10, there's 0.20, so here's 0.15, if you can see that at all. So it looks like 0.16 might be here. So these are all the values that are at or above 0.164 or 16.4%. Okay? So that means we only had 1 out of 100. Oops, sorry, 1 out of 100. So our p-value is 0.01. So again, to find the p-value, we always take the percentage of times that we see the special test statistic divided by our total. So, this is like 11B and 12B in your homework, but you won't be using 16.4%. You'll be using whatever test statistic that they give you, okay? The next goal for today is interpreting the p-value. When we're asked to interpret the p-value, we can articulate that in the following format. This is another template that we should use. There is a specific chance that this test statistic of at least this value will occur just by random chance. So let's practice interpreting this p-value that we found. So there is and it says to insert the p-value. Well, our p-value is 0.01. So we'll say there's a 1% chance that and now we insert the type of test statistic. Remember, this test statistic was the difference in winning percentage, clay minus other. So remember, that was the name of our test statistic. Of at least, because we looked greater than or equal to. So of at least, now we insert the value of the test statistic, 16.4%, will occur just by random chance. And that's how we interpret the p-value. We say that there's this percent chance that this test statistic that was at least this special would occur by random chance. So that's the template that we use. So again, this is the p-value, the name of the test statistic, the value of the test statistic. And you get to practice this template in 11C and 12C in tonight's homework. So now let's talk about guidelines for conclusions. In our conclusions, we always, notice this is in a big marker, we always discuss our alternate hypothesis, HA, okay? And this is that this is that 5% we were talking about. 5% is like 0.05 as a decimal. That's our cutoff. Remember, we said if something happens less than 0.05% of the time, that this is special. So what we say here is that random chance is not a likely explanation for this performance. Random chance is not likely. It didn't happen by random chance often. So because it didn't happen by random chance, that means it's special. So we do have evidence to support our alternate hypothesis, HA. Okay? In this case, it was special. It was special. It was different. It was a different ability. So again, if it's less than 0.05 as a p-value, it is special, so we do support HA. Now, if the p-value is greater than 0.05, that means that it totally could be random chance, that random chance is a likely explanation for the performance. Again, if it was more than 5%, that means it happened often in the simulation. Often in the simulation, that was random chance. So if it happened often by random chance, that means it wasn't really all that special. So that means that we do not have evidence to support, again, our alternate hypothesis, our HA. If it happened more than 5% of the time, it was not special. And if it was not special, then we can't say there was any difference in ability. Again, it was just random chance. Okay? In an AP stats class, they talk about rejecting the null or failing to reject the null. This author wants us to talk about the alternate hypothesis, just FYI. Okay? So those are our guidelines for conclusions. So now let's talk about stating conclusions. Stating conclusions, again, is something that we will do in Chapter 2, Chapter 3, Chapter 7, Chapter 10. So this is something we have to embrace now, and then our life will be easier the rest of the semester. Conclusions are always based on the p-value like we talked about here and should be in the following format. Since our p-value of whatever, and then we compare it to 0.05, and if it's greater than 0.05, we said we do not, but if it's less than 0.05, we said that we do have convincing evidence that our HA is true, and then we're going to write out our HA, okay? So when I say state HA, that means that we write it out, okay? I should not see the letters HA is true in the conclusion, okay? So here's what this looks like. In our simulation, our p-value was 0.01. So our conclusion would look like this. We would say, since our p-value of 0.01, and then we compare that to 0.05. 0.01 is less than 0.05. That's special. That means that we do have convincing evidence that, and then we write out our alternate hypothesis. If we look here, remember our, well, now it's written over it, but our alternate hypothesis was that Rafael Nadal has a greater ability to win on clay courts than other surfaces. Okay, notice here I wrote out my HA. That's what this is here, the alternate hypothesis. Okay, again, we just followed that template. Since our p-value of 0.01, we noticed it was less than 0.05. That means it's special. So we do have evidence that Rafael Nadal has a greater special ability to win on clay courts than other surfaces. Let's pretend the p-value was 0.26 instead. how would that affect our conclusion? Okay, we're just pretending. We would use the same template. We would say, since our p-value of 0.26, and now we want to compare that to 0.05. Notice 0.26 is greater than 0.05. That means it happened a lot in the simulation and was not special. So that means we do not have convincing evidence that our HA is true. And again, we write out our HA, that Rafael Nadal has a greater ability to win on clay courts than other surfaces. And again, you guys, I understand this is a lot of writing, but we are going to be doing this all semester, okay? And again, this is our HA that we wrote out. We always discuss HA in our conclusions, okay? Just use that template. Practice that template, right? This is what you guys would be using for like 11D and 12D on the homework, okay? That's what your answers should look like for 11 and 12D. And my note is that in a trial, notice that when the jury reads the verdict, that we use not guilty instead of innocent, right? They never say, oh, you are innocent. They say you're not guilty. And so for that reason, that's why the author wants us to say, like, that they're either guilty, which is accepting our HA, or not guilty, not accepting HA. Because being not guilty doesn't necessarily mean they're innocent. It just means there's not evidence to convict, just like there may not be evidence that we had here to show that he had a different ability, but there might be if we had different data, okay? Don't worry too much about that. The biggest things for today are making sure that you practice your hypotheses and finding the test statistic, that you understand how to describe what a dot plot displays, that you can find the p-value using the test statistic, that you can interpret the p-value, understanding that it's talking about the test statistic and random chance, and that you write conclusions using the p-value and your alternate hypothesis. Got it? Okay, get to work. Thank you so much. Take this homework seriously. It doesn't go away, all right? All right, have a great day.